Another series problem. Here we go. They told you what ln of 1 plus x is, and they're asking you to write the first 4 non-zero terms in the general term for the Maclaurin of f, given that f is x times ln of 1 plus x over 3. So, if ln of 1 plus x is equal to x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 plus dot 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 plus negative 1 to the n plus 1 x to the n over n. Now, first thing I'm going to do is do ln of 1 plus x over 3, but I'm going to leave a little bit of room because I'm going to multiply by x in a minute. Everywhere there's an x, I'm going to plug in an x over 3. So this is just going to be x over 3 minus, this is going to be x over 3 squared, and this 2 was still in the bottom. I'm just going to leave it, plus, this is the x over 3 to the 3rd, that 3 is still in the bottom, minus x over 3 to the 4th, that 4 is still in the bottom, plus dot 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 plus, and this is going to be negative 1 to the n plus 1, that x over 3 to the n, and that n is still in the bottom. Now, our problem is not f equals just ln of 1 plus x over 3, it's x times that. So I'm just going to multiply every term by x. So our equation is going to be f of x equals, this is x squared over 3, and 3 is going up by 1 power, so it's going to be 3 to the 1st, 3 to the 2nd, 3 to the 3rd, so I'm going to put 3 to the 1st. Minus, this is going to be x squared, I'm sorry, x squared times x to the 3rd, over 3 squared times 2, plus, this is x to the 3rd, x to the 4th, 3 to the 3rd, times 3, minus 4th x to the 5th, 3 to the 4th, times 4, plus dot dot dot, plus, this is negative 1 to the n plus 1, this is going to be x, this is to the n plus 1, over 3 to the n times n. And this matches. When n is 1, we have x squared, 3 to the 1st times 1. When n is 2, we have to the 3rd, 3 to the 2nd times 2. When n is 3, we have x to the 4th. So it matches. So we've got our first 4 non-zero terms in the general term. Part B, determine the interval of convergence. 100% of the time you're doing interval of convergence, you're doing the ratio test. Ratio test is the limit as n approaches infinity, the absolute value of a of n plus 1 over a of n, which is going to be the limit as n approaches infinity of the absolute value. So when I plug in n plus 1 here, I can omit the alternating piece because it's the absolute value. So this is going to become x to the n plus 1 is x to the n plus 2. So I'm going to write x to the n, x to the 2nd. That's the same as x to the n plus 2 over 3 to the n plus 1 is 3 to the n, 3 to the 1st. And then this is n plus 1. Instead of dividing by the original, I'm going to multiply by the reciprocal of the original. So this is just going to be 3 to the n times n over x to the n, x to the first. So I'm going to cancel what I can cancel. X to the n is gone, x to the n is gone, 3 to the n is gone, 3 to the n is gone, and one of these x's cancel with 1, and I'm just going to be left with 1x here. Remember the x term, I pull it out front, so this is the absolute value of x times the limit as n approaches infinity, and this is going to leave me n on the top over 3 times n plus 1. So this is going to be the absolute value of x times 1/3. And then I set that to be less than 1 to figure out the interval of convergence. So x is less than 3 and x is, flip it, greater than -3. So my interval of convergence is -3 to 3. That radius would be 3, but because it's asking for interval, I have to check my endpoint. So I'm going to check -3. -3 goes back into the original 4x. So this is going to be when I check -3. This was the summation from n equals 1 to infinity of -1 to the n plus 1. And now I'm plugging in -3. And I'm going to go ahead and break it up. So if this is -3 to the n plus 1, I'm going to do -3 to the n and -3 to the 1 over 3 to the n times n. Summation from n equals 1 to infinity. Now, this, if they have the same exponent, is the same as -1 to the n. Well, -1 to the n times -1 to the n is -1 to the 2n plus 1. This -1 to the n, when you multiply like bases, you add exponents, and n plus n is 2n plus 1, times that -3 over n. Well, -1 to the 2n plus 1 is always going to be negative because it's an odd. It doesn't matter what n you plug in. And a negative times a negative is a positive. So my new summation is just 3 over n, which I could pull that 3 out front. And what does 1 over n do? Well, in our class, we proved that it diverged by integral test. We also proved, then we did, I showed you p-series. We did this one several different ways. So this one diverges by p-series. P is equal to 1, which is less than or equal to 1. So -3 diverges. We're going to do a parentheses. And then we're going to check 3. So when I plug 3 into the original, this is going to become the summation from n equals 1 to infinity of -1 to the n plus 1. This is going to be 3 to the n and 3 to the first over 3 to the n times n. Well, these just straight up cancel. So now I have the summation from n equals 1 to infinity of -1 to the n plus 1 times 3 over n. So I kind of ran out of room, so I'm going to say it's alternating. And the limit as n approaches infinity of 3 over n equals 0, therefore converges by alternating. So this side's going to get a bracket. We've talked about interval of convergence, 1 point for setting up the ratio, did it. 1 point for computes the limit was 1/3. 1 point for the radius of convergence, that was the -3 and 3. 1 point for considers both endpoints. I considered them, and then the analysis and what happened on each end. Let P4 of x be the 4th degree Taylor polynomial for f about x equals 0. Use alternating series error bound to find the max error for P of 4 minus the actual f of a Taylor polynomial of 4, but minus the actual if you plugged in 2. So our error bound formula, y'all love it. Here we go. I'm going to write it down. So it's k over n plus 1 factorial absolute value of x minus a raised to the n plus 1. Now, if I'm using a P4, that's a 4th degree, so I'm going to do the one next. Do I have a 5th term? Well, I'm going to scoot back up, and I have a 2nd, a 3rd, a 4th, and a 5th. So yes, I can use the 5th degree. So it's going to be k over 5 factorial. X is what you're approximating, which is 2. A is what you're centered about. This is Maclaurin, so it's centered about 0, raised to the 5th power. Now remember, k is equal to the absolute value of the 5th derivative of 2, or the absolute value of the 5th derivative at 0. Nothing in this problem allows me to find the 5th derivative at what I'm approximating, so I'm going to have to use the 5th derivative at 0. So I'm going to use the 5th term. Now remember, it's the absolute value, so the negative doesn't matter. So, but it's going to be x to the 5th over 3 to the 4th times 4 is equal to the 5th derivative at 0, x to the 5th power over 5 factorial. That's just the formula of a Taylor polynomial with a degree of 5. So I'm just going to solve for the 5th derivative. So these go away, and I just have a 1 in the top. And if I solve for the 5th derivative at 0, the 5th derivative at 0 is 5 factorial over 3 to the 4th times 4. So this is my k value. So I'm going to plug this in for k. So this is the 5th factorial, 5 factorial over 3 to the 4th times 4 over 5 factorial times 2 to the 5th power. If I multiply by the reciprocal, oops, I write entirely 2. This goes away, and I get 2 to the 5th is 32 over 3 to the 4th times 4. 4 divides into 32 8 times, and 3 to the 4th is 3 times 3 is 9, and 9 times 9 is 81. And that's my max error. So my max error was 8 over 81. Boop, boop. And we used the 5th term, and we got our answer. Box it up. We're done. Thank you.